Hey, welcome back to ClearSpot. So, solar is growing faster than ever. Global capacity is actually doubling every 3 years. New installations are really ramping up, utility-scale projects are getting bigger, and distributed systems, well, they're just proliferating everywhere. But here's the problem, operations complexity is growing even faster than operations capability. Just 3 years ago, managing a 100-megawatt portfolio was considered challenging. Today that's pretty much normal, and by 2027, it'll just be table stakes. The operators who figured out how to scale operations in 2023 are now facing a completely different challenge. How do you scale further when manual operations have totally hit a wall, and the operators who didn't figure it out, they're about to be outperformed by those who did. And the operators who are just now realizing there's a scaling problem, they're already behind. This isn't speculation, this is happening right now, in 2025. In this video, we're going to break down exactly why autonomous systems are becoming essential, not in 5 years, but today. So, here's what's happening. Industry growth is really colliding with operations capacity. At the same time, grid requirements are tightening in real time, and competitor adoption is accelerating faster than ever. Margin compression is forcing everyone to get more efficient, and honestly, the 5 to 10 year competitive advantage window is shrinking, so let's dig in. This brings us to what I call the capacity paradox. Solar generation capacity is, growing exponentially. But operations capacity, think human operators, manual processes, SCADA infrastructure, is only growing linearly. And well, this creates a widening gap. Let's look at some actual numbers to make this real. Back in 2015, a large solar operator might have managed 200 megawatts with a team of 12 people. That works out to about 16 or 17 megawatts per person. By 2020, that same operator is managing 500 megawatts with a team of 18 people. Now that's 28 megawatts per person. So you can see the ratio has deteriorated. Fast forward to 2025, and that operator is managing 1.2 gigawatts with a team of 22 people. That's 55 megawatts per person. The workload per person has tripled in 10 years, and here's the thing. You can't keep doing this. At a certain point, which many operators are already hitting, you can't add more people. Labor is expensive, skilled labor is scarce, return on hiring diminishes. You've hit the scaling wall. Why does this wall exist? Human operations have limitations. There's a time constraint. 8 hours of human attention per day, maximum. Cognitive constraint. One person can meaningfully monitor 5 to 10 sites, not 50. Decision constraint. Complex trade-offs require simultaneous analysis of hundreds of variables. Consistency constraint. Humans make different decisions at 3 a.m. than at 9 a.m., thanks to the fatigue factor. Cost constraint. Adding people means adding overhead that erodes already tight margins. You could hire more people, but at what cost? Each additional person costs $60,000 to $80,000 annually, including salary, benefits, and overhead. To manage an additional 200 megawatts, you'd need 3 to 4 more people. That's $240,000 to $320,000 per year in fixed costs. The math doesn't work. At current margins, the labor cost becomes unsustainable. But here's how autonomous systems solve this. Autonomous systems don't hit the scaling wall. They scale logarithmically, not linearly. You have real-time agents managing each site. So, that's a fixed infrastructure cost. Adding a new site just adds a marginal cost, sensor integration, and a one-time setup. Plus, portfolio-level agents analyze across all sites, so the shared infrastructure means the cost pretty much stays flat as you add more sites. One autonomous system can manage 50 sites just as easily as 5 sites, and actually, the system's performance improves with scale. More data means smarter decisions. This is the fundamental difference. Humans hit a wall around 20 to 30 sites with current O&M models, but autonomous systems can scale to 100 or more sites without degradation. By 2027, every operator managing 30 or more sites will have deployed autonomous systems, or honestly, they'll have stopped scaling and ceded market share. The grid integration challenge. 10 years ago, solar was a small percentage of grid generation, maybe 5 to 10%. You plugged in, generated, got paid, done. But today, in some regions, solar is 40 to 60% of peak generation. California actually hit 75% renewable generation just last month, and when you have that much variable renewable generation, grid stability becomes fragile. So, the grid operator can't just accept whatever you generate. They need to ask things like, please reduce output, or provide frequency support, and sometimes even, inject reactive power, or be ready for rapid ramp-up. And, these aren't just friendly requests. They're actually requirements, and they're now embedded in the new grid codes. Regulatory requirements are tightening, with things like FERC Order 2222 in the US, European grid codes, and Australian AEMO regulations. All of these are moving in the same direction. Solar installations must respond to grid signals in real time. The requirements are, well, super specific. Frequency support has to be under 1 second response time. Curtailment response, less than 10 seconds. Reactive power injection needs to be under 200 milliseconds. And voltage support, that's got to be immediate. These response times are basically impossible for human operators. Your operator just can't see the request and respond in 1 second. You really need automation. But if you just use simple SCADA automation, that's kind of a one-size-fits-all approach. It curtails all strings uniformly, and honestly, it can't optimize your response. More importantly, these grid requirements aren't just about compliance anymore. They're actually becoming real revenue opportunities. Grid operators are willing to pay for frequency support, reactive power, and a bunch of other ancillary services. The US ancillary services market is over $50 billion a year, and it's still growing. So, who actually captures that revenue? Well, it's the operators with autonomous systems that can do things like predict grid stress 10 minutes ahead. So, they can buy low-cost energy and get ready for curtailment. They can also respond optimally to curtailment, minimizing revenue loss through smart dispatch. Plus, they can provide frequency support and earn $10 to $50 per megawatt hour for frequency response, and inject reactive power for $5 to $20 per megawatt hour. Operators who are still using manual processes or just simple SCADA, they can't participate. They're just too slow and, honestly, too simple. By 2027, the biggest grid service revenue won't come from generation anymore. It'll be all about ancillary services. The operators with autonomous systems are going to capture 60 to 70% of that market. And those who don't? Well, basically, zero. This is the new competitive dynamic. Every technology, follows an adoption pattern. It starts out slow, then it really picks up speed, and before you know it, everyone's got it. Right now, we're at that inflection point for autonomous systems in solar, right around mid-2025. Early adopters. They're utility-scale operators who managed over 500 megawatts of deployed agents back in 2023 and 2024. They're already seeing 20 to 30% operational improvements. They're capturing grid service revenue, and honestly, they're outperforming their peers by huge margins. Mainstream adoption is starting now. Pretty much every major operator is looking at autonomous systems, and most will have them deployed by the end of 2026. As for the laggards, by 2027, if you haven't deployed autonomous systems, you'll be operating at a 20 to 30% disadvantage compared to your peers. You'll either have to deploy under pressure or, well, exit the market. So, why is adoption accelerating right now? There are 3 main reasons. First, proof points exist. Early deployments have shown real results, real data, real revenue improvements. It's not just theoretical anymore, and that's honestly the #1 thing speeding up adoption. When competitors see their peers deploying and outperforming, they move quickly. Second, there's competitive pressure. If your competitor deploys autonomous systems and boosts operations by 25%, your margin advantage shrinks. Customers notice that, and they want the same operational efficiency, so you either keep up or you lose deals. And third, vendor availability. Solutions are finally becoming widely available. We're not just talking about research projects anymore. These are commercial offerings with support, service-level agreements, and proven track records. Deployment timelines have dropped from 18 months to just 6 to 9 months. The barrier to entry has, dropped dramatically. By 2027, operators who haven't deployed autonomous systems will face some serious challenges. First, there's a talent retention problem. Top operators are just going to gravitate toward forward-thinking companies that use modern tools, That means laggards will really struggle to hire and keep the best people. Then, there's the cost disadvantage. Manual operations cost about $50,000 to $100,000 per site per year in labor, while autonomous operations only cost about $20,000 to $30,000. So that's a $30,000 to $70,000 per site annual cost advantage for those using automation. If you multiply that by 20 sites, you're looking at a $600,000 to $1.4 million disadvantage. And let's not forget the performance gap. Autonomous operators will see 15 to 25% higher performance ratios, which translates to $50,000 to $200,000 per site in annual generation improvement. That's just massive. Plus, there's market exit pressure. utility operators will consolidate around best-in-class operators, and middle performers sticking with traditional operations will either be acquired or shut down. It might sound dramatic, but if you look at any mature technology market, you'll see the same pattern. The early adopters of new operational paradigms gain dominant positions, and the laggards, well, they exit. The margin squeeze is real. Solar is basically a commodity now, and capacity is abundant. In fact, supply actually outpaces demand in a lot of markets, which just drives electricity prices down. A 15-year-old utility-scale solar farm generates power at about $25 to $35 per megawatt hour, but new installations with lower capital expenditures are generating at $20 to $28 per megawatt hour. So, margins are definitely shrinking. At the same time, operations and maintenance costs have stayed pretty much flat. Back in 2015, O&M was about 0.5 to 0.75% of capex, and today it's still 0.5 to 0.75% of capex annually. That just hasn't changed. But as capex has declined, thanks to efficiency improvements and scale, O&M as a percentage of the operating budget has actually increased. Okay, so let's look at a 100 megawatt plant built in 2024. The capital expenditure is about $40 to $50 million. The annual operations and maintenance budget is somewhere between $200,000 and $375,000, which is roughly 0.5 to 0.75% of capex. Expected revenue is around $3 to $5 million a year, assuming $40 per megawatt hour and a 30% capacity factor. After O&M costs, the operating margin comes out to about $2.7 million. Now, fast forward to a 100 megawatt plant built in 2030, assuming prices keep dropping. Capex is now down to $30 to $35 million, which is about 30% cheaper. The annual O&M budget also drops to about $150,000 to $260,000, keeping the same percentage, but applied to the lower capex. However, expected revenue also falls to about $2.4 to $3.6 million due to pricing pressure. After O&M costs, the operating margin is now around $2.2 million. So, revenue has declined, O&M costs have stayed roughly flat as a percentage of capex, and margins have definitely compressed. So, how do you maintain margins in this environment? Well, you can't really reduce capex much further, since you're running into the limits of physics and technology, and you can't just increase revenue, because it's a commoditized market. That means really, you have to focus on reducing O&M costs. The traditional approach is to reduce service frequency, cut staffing, and just accept lower performance. But the result is that your performance ratio drops by 2 to 3%, and revenue actually drops more than you save on O&M, so it's a net negative. On the other hand, with an autonomous approach, you can maintain or even improve service frequency through automation, keep staffing lean, and optimize performance. The result is that your performance ratio stays stable or even improves. O&M costs drop by 30 to 50%, and revenue stays the same or even increases. So that's a net positive. The only way to maintain or improve margins in a declining price environment is, honestly, through operational efficiency. Autonomous systems, can provide a 30 to 50% reduction in operations and maintenance costs by doing a few key things. We're talking about a 90% reduction in false alarm investigation time, which is about $40,000 to $50,000 per site. There's also an 80% reduction in unplanned downtime, saving you around $100,000 to $150,000 per site. Plus, you get optimized scheduling and logistics, which can mean savings of $100,000 to $300,000 per site for portfolios. And let's not forget, automated maintenance optimization, which brings in another $50,000 to $100,000 per site. By 2027, if you haven't reduced your operations and maintenance costs through automation, your margins just won't be sustainable at electricity prices of $25 to $30 per megawatt hour. The operators who automate now, they'll be profitable even at $15 per megawatt hour, but the ones who don't, they'll be struggling to break even at $30 per megawatt hour. The 5 to 10-year window is, honestly, a huge opportunity. Right now in 2025, there's a massive competitive advantage available to early adopters. You can deploy autonomous systems at today's cost, and you'll outperform your peers by 20 to 30% for the next 3 to 5 years. You'll establish your market position, win more deals, attract top talent, and develop operational expertise that your competitors just won't be able to catch up to. But this window is closing. Fast. By 2027, autonomous systems will be table stakes. Everyone will have them. The advantage shrinks. By 2030, it'll be standard. Like SCADA is today, you can't compete without it. What this means is, if you deploy in 2025, you've got a 5-year advantage window before the competition catches up. If you deploy in 2026, that's more like a 3 to 4 year advantage window, because honestly, more players are moving. If you wait until 2027, you're looking at just a 1 to 2 year advantage window. Laggards are desperate to catch up by then. And if you deploy in 2028 or later, there's really no advantage. You're just keeping pace. The early adopter advantage is real. Look at any industry that underwent operational transformation. Airlines that invested in revenue management systems in the 1990s, when it was brand new, now capture 2 to 3% additional margin compared to their peers. That's, honestly, billions in total value. Retailers that invested in supply chain optimization early, back in the 1990s and 2000s, captured a 10 to 15% cost advantage and, well, they dominated their market. Manufacturing plants that adopted predictive maintenance early gained an 8 to 12% efficiency advantage that still persists to this day. The operators who adopt autonomous systems in 2025 will establish advantages that persist for decades. The ones who wait, they'll be playing catch-up forever. Here's the reality. Solar is growing. Grids are getting complex. Competition is intensifying. Margins are shrinking. Every single one of these trends creates pressure to modernize operations, and together they make it not just beneficial, but honestly, essential. The operators who understand this urgency and act now will lead the industry in 2030. The ones who wait, they'll be fighting for survival. If you're managing solar assets, this isn't a nice-to-have conversation anymore. It's a how-do-I-get-started conversation. In the next video, we'll walk through exactly how to begin implementing autonomous systems, step by step, what you need, what to expect, how to phase it in. Like, share and subscribe for more solar insights. ClearSpot. Smart device. Smarter decisions.